This is another redox reaction taking place in an acid. First thing, look for changes in oxidation state. I can see here I have a bromine ion and then elemental bromine. -1 to 0. So this has lost electrons, so it has been oxidized. Oxygen has a -2 oxidation state. The total charge of oxygen is -8. To have a total charge across the entire compound, manganese must be +7, and it is being reduced to +2. Now I can set up my half reactions. I'll start with bromine. First, I need to balance out the number of bromines. I'm going to add a 2 over here. Now that that is balanced, there's nothing else to balance out. I must balance the charge. Forgot to add this over here. Bromine loses electrons. So the electrons are going to need to be added to this side over here, and here bromine has a -1 charge and it goes to a 0 charge. I'm going to need to add 2 electrons since there are 2 bromines. This is completely balanced now for the time being. Now I need to turn my attention to the manganese. There are equal number of manganese on both sides, so therefore I need to balance out the oxygen next, and I can do that by adding H2Os. 4 of them to be precise. Now that I've added H2O to the right side of my equation, the product side, on the reactant side I'm going to need to account for these extra hydrogens I've added. 4H2, 8H+. Well, this is aqueous and liquid, I forgot. I'll make sure to Now that I have a balanced number of hydrogens, oxygens, and manganese on both sides, now I need to take account for the charge. The charge difference is 5 electrons. Manganese is gaining 5 electrons in the product side. Therefore, there are 5 extra electrons on this side than this side. So I add 5 electrons to the reactant side of my equation. And that's what I would expect, because for bromine I added 2 electrons to the product side. And this is the balanced half reaction for manganese. Now I need to add these two equations together, but I cannot do it right away because I have unbalanced charges. I have 2 electrons being gained on the product side and 5 electrons on the reactant side. I need to find the lowest common multiple, which is 10. I multiply this reaction by 5 and this reaction by 2, and then I can add them together. Or I can just do it in a single step. And I will do that because it will take a long time otherwise. So I'm going to add 5 times 2 bromines. Or I'll do this one first. This one has more stuff. 10 electrons. Do I have the proper color? Yes, I do. 10 electrons. This will be 16 hydrogens. And now 2 MnO4. And now I need to take into account for bromine 2 bromine ions times 5, this is 10. So this is the reactant side of the equation. Now I need to do the products. 2 times Mn2 plus, 2 times 8, or 2 times 4 H2O is 8. And then 5 times Br2. And 5 times 2 electrons. They have been added to both sides. Now I need to cancel any like terms out if any do exist. I see hydrogens, there are no H pluses on this side, no waters on this side. All that needs to be canceled are the electrons. Cancel those out, and then I have my balanced equation. Actually, I'm not going to write this out again, since the electrons are just on the outside. So the final equation is 16H plus 2 MnO4 minus plus 10 Br minus gives 2 Mn2 plus aqueous plus 8 H2O plus 5 Br2.